Hi everyone. So today we'll be discussing our second topic, embedding model. So we'll go through what is embedding model and why we need that. So let's start with the problem statement. So this is just one of the stimulate I have created, where you give the any PDF document, and then we ask any question. It will go try to answer that. So let's go through that. Let's understand the problem statement first, and then we'll understand what is embedding model. So I just uploaded this document. It contains detail about different companies, and then we are going to ask some query. Okay, what is OpenAI? Let's start with this one. So in backend, what it is doing, it is calling LLM, Gemini LLM, and it is passing entire PDF and then trying to scan and generate the answer. So what is happening? The moment I ask this question, I'm giving this entire PDF to LLM, and then LLM is generating the answer. The problem with this is, okay, in real scenario, this PDF can be too big. It can have thousand, it can be of 1,000 page, or there can be multiple PDF. So every time if you ask question and if LLM has to analyze the entire PDF, it might take longer time. It might hallucinate, and there's chance definitely the cost will be high because the number of tokens will be more. That is where we use embedding model. Okay, so first, whenever any question is coming, what we do, we use embedding model. We embed that particular text, and then we try to get the content from PDF. So instead of passing entire PDF, right, we go and get, okay, in PDF which all page content details related to OpenAI. So embedding model, what it will do, it will filter and it will give you, okay, page one is something where we have details about OpenAI, and then page one is something we pass to LLM. So instead of passing the entire PDF, we just go and pass this particular page. With this, okay, you can reduce hallucination, you can reduce the cost, even your performance will be better. So let's try to understand. So this is just one of the Hugging Face page. So let's suppose what device is used to take photographs. So here I have given four options: a camera, a bicycle, refrigerator, some the four different statement. So what it is doing, it is trying to find the closest match. Okay, so here we are asking about photograph. Ideally, this is the one which should be the closest answer. So if you calculate similarity, so what does it says? 0.80. The higher the similarity score means the closest is that particular sentence to the question. So with this question, this is the closest sentence. So in real scenario, how it will work? Okay, you'll get some user query, you'll pass different chunk of PDF, and then with the help of embedding model, you'll get the closest chunk, and then you pass that to LM and ask LM to generate the answer. So I can show you some quick example. So here I'm going to use um, Gemini model. So let me start with explaining details on the embedding model. So how does this work is, so this is nothing but whatever text you are passing to the query, right? So let's suppose here in this scenario, I pass what is OpenAI. So what does is, so it will take the meaning of that question. It will not go and get the exact word and all. It will try to understand the semantic meaning, and then there will be some representation, vector representation of that. So if you're passing two word, right, so there will be two different vector representation. So let me show you how it works. So let me try to comment this entire code first. So here what I'm doing, I'm importing from Google, I'm importing GenAI. This is just to load the environment. And then API key I have stored in the environment variable. And this is the function. So in this function, so we are calling this embedding model, Gemini embedding to preview. And this function accept a text. So you pass any text, something like OpenAI or whatever text you want to pass. And what we're trying to do, task type is we're trying to get the semantic similarity. So you have some question and then you have multiple content in PDF, or it can be anything. So with that text, you try to compare which is the closest match. So let's suppose if I do this one, let me run this. So this function, what it does is it will give you vector representation. So some sort of location in a multi-dimensional vector space. So let me quickly explain you what does that mean with a simple example. So yeah, let me show you how does this work. So suppose there are three texts. First one is what device is used to take photographs. Second, and this, let's suppose this is a question, and then we have some content in PDF. Let's suppose we have only two content. One is a bicycle is used for transportation. Second one is mobile camera is used to take photograph. So in case if we don't use embedding model and we ask LLM to generate the answer, okay, this is a question and these are the knowledge you have, try to generate the answer. So LLM will scan both and it will give you some answer on top of that. Since here we have only two records, it's okay. But in case if you have very vast knowledge base, it will take a lot of time, cost, and then chances of hallucination. That is where we go and use embedding model. So how that embedding model work is, so first thing what it does is, so everything, right? So this is what device is used to take photograph. So it will have some numerical representation for that, and that numerical representation is nothing but some location in vector space, and that is very high multi-dimensional vector space. So let's suppose we take example with two-dimensional vector space. So this is, let's suppose, y, and this is, let's suppose, x. So what device is used to take for? So it will have some location in vector. So let's suppose this is a location for the first one. Okay. And then next one is a bicycle used for transportation. So what we do, we pass this thing to Gemini model, and then it will give some location in multi-dimensional vector space. So let's suppose this is somewhere, since it is not close to this photograph one, it might be somewhere, let's suppose here. So let me take this pen. So this will be here. Third one is mobile camera is used to take photographs. So mobile camera, let's suppose it start something like this. So whatever you are seeing in this, right? Let's suppose when I ran this, so get query embedding. So get query embedding is nothing but it's calling this particular model, and we are passing the text, whatever is going through this function. It is giving some location in a vector space. So first thing, what does embedding model do? It gives a location in multi-dimensional vector space, something like this. So this is, let's suppose this is the first one, this is the second one, bicycle one, and this is the third one. Now with the help of this function, what you got the location in a vector space. So how does this work? How does this location come? So if you ask something similar, so if you're asking something and if you have knowledge base something related to that only, OpenAI, then those two will get located in nearby location, so they will be kind of neighbor to each other. So that's how it works. So it gives you the location first, and then we use the cosine function to get the distance. So let's suppose this is the function. I'll show you later in this code as well. So how that cosine function works? So it will, so first, so we are trying to compare what device is used. So this one we are trying to compare with both the one, right? So we want to know the vector location for each. So 1 versus 3. So it will have some angle, right? So this angle will do cosine. So the higher the cosine value for this, so if angle is less, cosine value will be more. If angle is more, cosine value will be less. So the higher will be cosine value of that. That means it is more close. So if you compare 1 versus 3 and 1 versus 2, right? So 1 versus 2 has higher angle, and cos theta, if you do from 0 to 90 degree, if cos 0 is 1, cos 90 is 0, right? So from 1 it will go to 0. So lesser the angle, higher is the value. Higher is the value means, okay, these two are more close. So if you see the angle between 1 and 3 is less, that means these two are more closer. So what we do, okay, we take the text, whatever user is asking, we give them the location using the embedding model, and then whatever knowledge base we have, for the knowledge base also we give the location in a vector space, and then there are multiple, then we do the then we try to calculate the distance, which one is closest. So the closest one is the one we will pass to LLM to generate the answer. So in this case, what device is used to take photograph? We did the embedding of both, and then we figure out mobile camera is used to take photograph is the one which is very close to what user is asking. So we pass mobile camera to the LLM, and then we ask LLM to generate the answer. So instead of sending the entire knowledge base, we go and send only the closest ones. With that, you can reduce the chances of hallucination. So let's see how it works here. Okay. So now, let's suppose, let me show you this example till here. Yeah. So I have taken four examples. So first thing, vector one. So I'll do the vector of this. Vector of this in the sense location of that in some vector space. Okay, so it will be okay. Let's skip this only. Okay, so first I'll get the location of this, then I'll get, and then let's suppose three examples. So what device is used to take photograph, and then we have three knowledge base. First one is a bicycle is used for transportation. Second one is mobile camera is used to take photograph. Third one is Delhi is capital of India. So we have three knowledge base. Either we send everything to LM, which is not practical. Here, in this example, it might be practical, but in real scenario, it might not be practical. So that's why to explain you, I have taken simple example, so it will not complicate. It will not be very much complicated to understand. So, what device is a photograph? And then what we'll do, we'll get the vector location of each four text, and then we'll say which is the nearest. So, nearest is the one which has very high score. So, which is the nearest to this? That is what we'll pass to LM. So now let's suppose vector for this. Let's print the vector for this as well. Print sorry, vector two, vector three, and print vector 4. So this is a model. You pass any text to this, it gives you a location of that in multi-dimensional vector space. So let me run this. So if you see here, right, all four, we got some vector location. So this is dimension. Okay, it's like, let's suppose if it is xy, right, it will come zero point 0.4, comma zero point 0.2, something like that. It will come. Okay, but it's a multi-dimensional vector. So so what we did with by calling this function, we got the vector location for each of the text. So one what user is asking, and the rest what all we have in our knowledge base. So now what you have to do after this is done, we will get the similarity score. Which one is similar? So first thing what we'll do to calculate the similarity score, this is the formula. So similarity score is 1 minus cosine vector 1 to vector 2. So what we are doing, first we are comparing vector 1 with vector 2. Okay, how similar it is. In the second one, what we are comparing, let me print this out. In the second one, what we are doing, let me print. Yeah, in the second what about it? So my question is this. So if I will compare this question with all three. So first one I am doing distance between similarity score between vector 1 to vector 2. Second one vector 1 to vector 3. Third one vector 1 to vector 4. So let's do 100 score out of 100. 4, 1, 2, vector 2 is this. Let me write here so it is more readable. So this will be, see, 4. Okay, so let me run this. Okay, so if you see here, right now, let me remove this vector piece so it will be more readable. Yeah, let me run it again. Okay, so first one is what device is used to take photograph. So first similarity score out of 100 for vector 1 to vector 2. So vector 2 is this. So what device is used to take photograph? A bicycle is used to turn. So it has given 51% similar. So it has given 51% similar for the first one. Second one is what device is used to take photograph? So it's between vector 1 to vector 3. Mobile camera is used to take photograph. So second one, it has given 78%. Third one, it has given Delhi is the capital of India with the first one, right? So similarity score out of 100 for vector 1 to vector 4 is 47%. So now once you have this score, right? So it's some sort of probability. Okay. So always it will be from 0 to 1. So I've just converted this into percentage. So it's more readable. So that's why I've done this into 100, but it's generally between 0 to 1. Okay. So now if you see which one is the most closest one, 78%, right? It's a 78% match. It's giving you a match score. So it's a 70%, 78% match. So now vector 1 to vector 3 is the highest one. So what I will do, I'll pass this question to LM, and then instead of passing all three, I will just pass this mobile camera is used to take photograph. Okay, and in that case, and then I ask them, hey, can you generate this answer? This is a question, this is what we have found in knowledge base. Can you just generate the answer? So the benefit of this is, okay, you don't need to pass the entire content, which might be very vast. So you go and use embedding model, try to understand what all closest match you have, and then you go and send it to them, hey, this is the closest man, now closest match, now you go and generate the answer. And this is not based on the word, it's based on the understanding. Understanding the semantic meaning of that. If you keep laptop camera, it still it will work. So if I keep laptop camera here, right? Then also, sorry, let me comment this out. See, still it has given you highest score, 75% score. Okay. Now if you give physical camera or any camera or DSLR camera, 79%. Okay. If I just put camera, 85%. Okay. So it's always based on the semantic meaning. There is no word to word match. What user is asking, it gets the meaning of that, and then it goes and scan based on the vector. So it gives you vector dimensional location in a multi-dimensional vector space, and then it figure out the closest one. Okay. So thanks everyone for watching. And in next session, we'll be discussing on the vector database, why we need vector database. Thank you so much.